In this video, we're going to take a look at parallel circuits and Ohm's law, how it works with a parallel circuit. Keeping in mind that this video is intended to support what you've read in the book and also working with parallel circuits out in the shop. Parallel circuits can be identified by having two or more paths for the current to flow through, and there's really no limit to the number of paths that you can put on there. Our source is going to be a battery, or on the car could be the generator. Conductors is going to be our wiring or the frame or body of the vehicle. And the load's typically going to be lights, but it could be solenoids, motors, whatever they happen to have wired up on there. Our three laws of a parallel circuit. So if you've read through the book, they would have given you 4 or 5 different laws of a parallel circuit. But for the series circuit, for the parallel circuit, and for the series parallel circuit, I always break it down to 3 laws. One law dealing with volts, one with amps, and one with resistance. So on this one here, we're looking at voltage for our first law, and that is voltage applied to each branch is the same. So comparing that to a series circuit, on a series circuit, if you have multiple loads on there, they all have to share the available voltage. Law number 2 on amperage. Total current is the sum of each branch current, or each branch amperage. And on a series circuit, because there was just one path, current had to be same everywhere. But on this one, if I have a different resistance on a branch, it will have a different current. And then that's adding those together is going to give you total. Law number 3 is resistance, and that is total resistance is always less than the least restrictive branch. And this can become confusing because you look at a circuit, it has 10 ohms or 100 ohms, and you look at this circuit with a 100 ohm resistor in there, and you have to wonder, how is my total resistance less than 100 ohms? So we'll talk about that, and it'll make sense. So in this example, we're going to take a look at a simple 2 branches on here. So keeping in mind that this part right here, as well as on the negative side, that's a series portion to a parallel circuit. So from the positive side of this, I have 12 volts at this point right here. As it comes through here, I'm not coming across any significant resistance. So that means I'm going to apply my battery voltage right there. Now, if you were to measure this, you would measure 12 volts at your battery, and then you come over here and measure the voltage applied, and you would find maybe 12.85 or a small voltage drop. And that's because we're going to come through a fuse or two, a switch, the wiring, no superconductors, so everything has a little bit of resistance, so we will have a small voltage drop. But what you'll find is the voltage applied to each branch is going to be the same. If we want to use Ohm's law on this, first thing that we need to do is we need to figure out what is our total circuit resistance. So I've got my voltage applied, but I only have my individual resistances. I need to know what total resistance is in order to figure out what my total amperage is. And this is where the math part comes in. So there's several different formulas that you can use. I encourage you to research that, find the formula that you like, and work with that one. So there's not just one right way to do this. The one I'm going to show you on here is the one that students generally like the best. So R1 is a 6 ohm resistor. Resistor 2 is a 6 ohm resistor. So the formula up here at the top, R1 times R2 divided by R1 plus R2. So I'm going to have 6 times 6 divided by 6 plus 6, which gives me my 36 over 12. So 36 divided by 12 is going to be 3 ohms. So my total circuit resistance is 3 ohms, and my amperage is 4 amps when I use 12 volts divided by 3 ohms, gives me 4 amps of total current. So here we have it. Our total resistance is 3 ohms on a circuit that has 2 6 ohm resistors. So my total is less than each branch amperage. So what you need to keep in mind is if I were to add another path to this, that's what I'm doing. So picture a group of students in a room, teacher does an experiment, and suddenly things catch on fire up there in the front. And all the students have to start running out the door. If there's just one door for them to run out, it's going to take a while. But if there's 2 doors for them to run out, theoretically at least, we can get the room cleared out in half the time. So what you're doing is you're not adding another resistor to a parallel circuit. What you're doing is you're adding another path for the current to flow. The more paths there are, the more current that can flow. And with Ohm's law, if your amperage decreased, pressure remained the same, or my voltage remained the same, resistance had to decrease. So with each path that we add to there, our resistance is going to decrease. Now, taking a look at each branch on here. So I have my 12 volts, and that's applied here. Here at the negative post of the battery, I have 0 volts, no significant resistance, so I'm going to have a 12 volt drop across this R1. So 12 volts divided by 6 ohms equals 2 amps. We're going to repeat that over here, another 2 amps here. So the amperage through R1 is 2 amps. Our amperage through R2 is 2 amps, which gives us 4 amps of total current. Now, comparing that to here, where we came up with 3 ohms of total resistance and 4 amps of current flow, now we just went through, figured out our amperage from 2 different directions, and we got the same answer, meaning we did it right. So let's take a look at one more circuit, and in this one we'll add a 3rd branch on here, so we now have 3 branches with 15 ohms. So come back up and look at our formula, our R1 times R2, so up here, divided by R1 plus R2, so 15 times 15, 225, 15 plus 15 is 30, 225 divided by 30 is 7.5. So now we have to do this formula again, but we're going to take this value as R1 to go here, and our R3 is going to go here. So 7.5 times 15 equals 112.5. 7.5 plus 15 equals 22.5. 112.5 divided by 22.5 equals 5 ohms of resistance total. So you may want to pause it, take a look, and figure out what I did there. Now that I know what my total circuit resistance is, 5 ohms, 12.5 volts, divided by 5 ohms means I have 2.4 amps of total. So if I were to measure the current at this point right here, I would measure 2.4 amps of current, which is my total. Now we can go through and calculate it from the different direction and see if we did this correctly. So again, I have 12 volts applied to R1, to R2, R3, and then from this side, again, there's no significant resistance, so negative post of the battery is always going to be 0 volts, and that means we're going to have a 12 volt drop across each of our resistors there. So 12 volts divided by 15 ohms equals 800 milliamps, or 0.8 amps. So resistance is the same on each current or each branch. So law number 2 with amperage, add your amperages together to equal your total. So 3 times 0.8 equals 2.4 amps, which that was the same we came up with here. So again, we figured it from 2 different directions, came out with the same number, so we did our math correctly. Now, if you have access to a series parallel trainer where you've got a circuit that you can play around with, set it up, and test it and see if you can prove this to be true. And that concludes our video on a parallel circuit.